Okay, good evening, ladies and gentlemen. This is Professor David J. De Los Reyes. I will be discussing tonight an improved uh, assembly of the so-called DC voltage generation by using a combination of a copper wire or rod or aluminum rod submerged in a Clorox to generate DC voltage. So I improved the construction of the the voltage generation gadget. So each container here contains Clorox and submerged in it one copper rod and one aluminum rod, and so with the other 5. So inside the containers are actually in a copper rod and aluminum rod submerged and a Clorox. And for the voltage to come out as a big one, I made the connection, series connection. So the positive here goes with the negative, positive here goes with the negative, and the positive here goes with the negative, and the positive here goes with the negative, and the positive here goes with the negative. This will be positive. What comes out here is negative. So the output terminal will be on this portion here. That's the end of the series connection. For the negative terminal, this will be the start of the first terminal. So it seems that I added the voltage in each of the containers. So I could generate a greater DC voltage. So actually, I place across it a DC voltmeter, and what comes out is 7.20 volts for these 6 containers. It's an average of 1 point something volt per container. If we try to divide, I will try to divide 7.29 divided by 6. That will be a voltage in each cell of 1.215. So it seems we are having a battery in which each container represents a battery, and the voltage across each is 1.215. And since we got 6 here, the total will be around 7.18 volts. Okay? The connection is actually series. Okay? So this is one way of generating a DC voltage in which we could power up some low power LED lights during brownout time. Okay? During brownout time. So I will repeat it. The voltage generated in each container is 1.215 volts. And since there are 6, 1.215 times 6 is around 7.18 volts. The connection is series. Okay? The one inside is combination of a submerged copper rod and aluminum rod. The concept of this one, if we try to submerge these two different metal here, they will try to generate a voltage across the aluminum and the copper rod. And since the connection is series, the voltage that will be generated across the plus and the minus terminal is 7.20 volts. So I will now try to use this one. Okay. I will try to remove the multi-tester And I got here an LED lamp. Okay. Actually, I removed the battery part of this one. The voltage of this one should be around 6 volts. So, since the voltage generated by the 6 containers is 7 volts, I think this one could light up this one. So, this should be the negative terminal. That's the terminal that goes to the terminal of the LED light. So, this is the terminal coming from the one that was assembled. Right? And the negative terminal is, and the positive terminal is on the other side. So right now, I have connected the negative output and positive output coming from the assembled combination of 6 containers. Like we have passed by a while ago, the generated voltage is 7.20 volts. And since I connected this one already, we could try to power up if it really works. Okay, I will try to pause the switch. Okay. And it generates a DC voltage, not so bright enough, but it lighted this Petromax style LED lamp. So this is a free energy now. So just in case there will be a brownout, I could use this one to just light up something inside our house. So we could see the things we are doing during brownout time. Like what I said, the voltage generated by the 6 volt is 7.20. I connect it to my Petromax style LED lamp. It was lighted. Okay. It's not so bright, but it was lighted. Okay. So for now, this is Professor D.B.J. De Los Reyes, and what I have presented is that a combination of a copper rod, an aluminum rod, submerged, and any bleach thing. The bleach I use here is Clorox, and I will repeat it for the last time before we go for tonight. The voltage generated in it is 1.215 volts, so that's around 7.20. And this Petromax style LED lamp, the voltage requirement of this one is actually 6 volts. And it was lighted by this assembled voltage generation equipment. Okay? It's a new concept on how to bring out a DC voltage, and we could use it during brownout time. Okay? Good evening from Los Angeles. This is Professor D.B.J. De Los Reyes.